Hi folks, welcome back to 3.2 part 2. And in this video, we're going to take a look at vertex form of a quadratic function. And so the vertex form of the quadratic function is as follows. Y equals a times x minus c squared plus d. Okay. Now, one thing to keep in mind here, this squared, that's the part that tells us we have a quadratic function. Okay. Other than that, the A, B, and C should look pretty familiar, okay? Our A is one of our graph transformations, right? Our C is another one of those graph transformations. And lastly, D is a third one. And excuse me, this should say A, C, and D, not A, B, and D. Now, we're not going to focus on B very much, the horizontal stretching and shrinking of the parabola. We are mostly going to focus on the vertical stretching and shrinking, and then moving the parabola side to side and up and down, okay? So as a quick reminder, if A is greater than 1, we have a vertical stretch. Okay, and if absolute value of A is greater than 1, if the absolute value of A is less than 1, we have a vertical compression. Okay, and I want to squeeze this in here. Negative A means a reflect over the x-axis, right? We reflect over the x-axis. So lots of things happening for A. C and D get a little bit more straightforward, right? A positive C shifts left, and a negative C shifts right. Okay. Now, the D is the one that is exactly what you think it is. A positive D shifts up, and a negative D shifts down. Okay. So little reminders, but if you need more of a review, you can go back to 1.5 and study those graph transformations again, okay? So the vertex form of the quadratic function is useful for some things. And in particular, it's useful for finding, finding the vertex, okay? And I would say that it's least useful for finding x-intercepts. Okay, that's going to be hard for us to find the x-intercept. Not impossible, it's just going to require us to do a little bit more work, okay? All right, let's take a look at an example. Take a look at example 1 here. We've got y equals x plus 3 squared minus 4. And so one of the things I might notice is this minus 4 here. All right, this is my graph transformation that moves the graph down 4. But I also have this plus 3, and that graph transformation moves the graph to the left 3 units. And so before I start filling numbers in the table, you'll notice that there's 1, 2, 3, 4, 5, 6, 7 of these. We're going to take our vertex coordinate and put it right in the middle, okay? So in other words, 2, 3, 4, we're going to have -3, -4. That is where our vertex is, okay? We can even plot that right away, -3 and -4. So 1, 2, 3, 1, 2, 3, 4, okay? Now, I want us to choose numbers that are smaller than -3 and then larger than -3. So larger than -3 would be like -2, -1, and 0. And smaller than -3 would be -4, -5, -6. Okay, and now we're just going to plug these numbers into the equation. And I'll give you a moment to do that, all right? But once you do that, you should end up with the following values. When I plug in -2, all right, -2 plus 3 is 1. 1 squared is 1. 1 minus 4 is -3. So I could go ahead and plot that point. If I plug in -1, let's see, -1 plus 3 is 2. 2 squared is 4. 4 minus 4 is 0. So I can plot that point. And last but not least, if I plug in 0, I get 3 squared, which is 9, minus 4, which is 5. So I've got this as half my parabola. But instead of plugging in the other 3 numbers, here's what I'm going to do. I'm actually going to use the fact that I know a parabola is symmetric about the vertex. And I know that if this point is here, then the other point is right here. And same thing, this point will be reflected, this point will be reflected 2 over. And this point will be over here. And then I could connect everything to make a parabola. Okay, so I'm going to use the idea of reflection, which means -4 has a y value of -3, -5 has a y value of 0, and -6 has a y value of 5. Okay, so we're being efficient and we're being clever about how we're plugging in these numbers. So let's go ahead and sketch that out. We've got a parabola right here. All right, that's good. Now let's find out these different characteristics, okay? So determine the domain. The domain of every quadratic function is -infinity to infinity. And the range depends on where the vertex is, okay? So I don't see any values below -4, but I do see a value at -4 and then everything above it. So my range is bracket -4 to infinity, okay? All right, now the coordinates of our vertex, -3, -4, that was this point right here. All right, we can write that right here, -3, -4. All right, and that was something on the previous page. I had said this vertex form is really useful for finding the vertex. That's how we named it, the vertex form, okay? All right, now once we have the vertex, our axis of symmetry, okay, so let's sort of draw that in. Our axis of symmetry would actually be right here. All right, that vertical line that goes right through the vertex. Now, because it goes through the vertex, it actually shares the same x value as the vertex. And so in this case, our equation for the axis of symmetry would be x equals -3, okay? Now, it would be really important you put this x equals here, right? If all you put was -3, I'm going to mark that wrong because I don't know what you mean by -3, okay? You got to be specific. X equals -3. All right, let's find our y-intercept. So for every y-intercept, that means put in 0 for x, and out comes a number. So let's grab our equation here, all right? And let's plug in 0 and see what happens. F of 0 equals 0 plus 3 squared minus 4, which is 9 minus 4, which is 5. But we don't want to stop here. We want to show that we know it's a coordinate and write it like 0, 5. Okay, this is our y-intercept. And we can see it right here on the graph, right there. Okay. All right. Now, I did tell you on the previous page that finding the x-intercept is hard for vertex 4. So we're going to walk through this one together, okay? But we're going to start by writing down our equation. And we're going to write that equation equal to 0 because the x-intercept is always a number, comma 0, okay? So 0 equals parentheses x plus 3 squared minus 4. Okay. All right. Now we're going to go ahead and do a few things, okay? We're going to go ahead and FOIL this out. All right, we're going to go ahead and FOIL this out. This is going to give us 0 equals x plus 3 times x plus 3 minus 4. Now I'm actually going to write it x squared, let's see, plus 3x is plus 6x, plus 3 times 3 is 9, and then minus 4. And then finally I get 0 equals x squared plus 6x plus 5. Okay. Now, what we're going to do is we're going to factor, okay? Now, I want to talk to you about the way that I factor. I found that this way is really sort of an easy way for students to learn how to factor. But I'm going to say this once and now, and I'll say it again later, probably multiple times. It is so important that you know how to factor by the time you leave this class, okay? Calculus is infinitely harder if you don't know how to factor, all right? So I want to be upfront with you about that. All right, so here's what we're going to do. We take our factoring. We're going to start by drawing an x. And on the top, I'm going to take this number and multiply it together. So really, I have 1 times 5, which gives me 5. And then I'm going to take the middle number and I'm going to put that in the bottom, 6. Now I'm going to think, what numbers multiply to make 5, but add to make 6? Well, we've got plus 5 and plus 1. 5 times 1 is 5, but 5 plus 1 is 6. And so here's what that means. This plus 5 and plus 1 means that instead of writing plus 6x, let's unsimplify it and write it as plus 5x plus 1x. And then we still need the 5, okay? So just so we're aware of what happened, this plus 6x became plus 5x and plus 1x. It's like I unsimplified it, okay? The reason why I unsimplified is now I'm going to factor these first two, and then I'm going to factor these second two, okay? So what goes into x squared plus 5x? Well, an x. When I factor out the x, I get x plus 5. Okay, all of this comes from that first pink bracket. Plus, what goes into 1x plus 5? Well, just 1. So plus 1, x plus 5. Okay, now here's the cool part. This is x plus 5, and so is this. That means you did it right. It means that you factored correctly, okay? We're so close to being done with the factoring. We're going to get 0 equals x plus 5. This is the x plus 5 here and here. We're pulling that out to the front. And what's left? X plus 1. Okay? This, my friends, is factoring. You factored. Okay? We're going to practice this a lot more. You get to practice it in your MyOpenMath. You're going to practice it on the quiz. You're going to practice it for the test too. Okay, so let's make sure that we get a lot of practice for this. All right, now we're not done yet. But the beauty of saying 0 equals a bunch of stuff is now we can actually say x plus 5 equals 0 and x plus 1 equals 0. If two things multiply to make 0, one of them has to be 0, right? That means x could equal -5 or x could equal -1, but that really means we're looking for x-intercepts, right? So we're going to write it like -5, 0 and -1, 0, right? These were our x-intercepts. I choose purple. Okay. These were our x-intercepts here and here. And we can even see them on our graph right here and right here. Okay, so let's get that all on one page for you. All right, so looking through this whole problem, we've done a lot of things, multiple representations. We got an equation, a graph, a table. We can find the domain and range, the vertex, axis of symmetry, and both the x and the y intercepts. All right. All right. I'm going to go ahead and take a look at example 2. All right, example 2. I have a +6. That means I move my graph up 6. I have a -1, which means I move my graph to the right 1. And that, my friends, is right where my vertex is, 1, 6. Okay. I also want to be careful that I have a reflection here. So at the end, my parabola should be facing down. Okay. All right, let's start with our table. We're going to start with our 1 and count numbers higher, 2, 3, and 4. And then we're going to count down from 1. So 0, -1, -2. All right, let me graph my vertex, 1, 6. 4, 5, 6. All right. And let's plug in some numbers. So I'm going to plug in 2. 2 minus 1 is 1. 1 squared is 1. And then I have to make it negative. So -1 plus 6 is going to give me 5. And I know from symmetry, if this is 5, this is also 5. So I can plot those two right here, 5 and 5. All right, let's plug in 3 now. 3 minus 1 is 2. 2 squared is 4. Then I make it negative. So -4 plus 6 is 2. And if that's 2, this is 2. Okay, so 2 and 2. All right, last but not least, let's plug in 4. 4 minus 1 is 3. 3 squared is 9. -9 plus 6 is -3. So 1, 2, 3, and 1, 2, 3. All right. So I've got a lovely parabola here. We're going to go ahead and connect these. Nice smooth curve. All right. So let's find our domain. We don't need to think about it too much. -infinity to infinity every time we have a quadratic. But the range this time, there's stuff missing up here, but I do get as high as 6 and then everything underneath. So the way I write that is I say from -infinity to 6, and I say 6 is the cap. We can't go above 6. Okay. All right. coordinates of our vertex. This vertex is 1, 6, 1, 6. And from our equation, 1, 6. So there's our vertex. Okay, what's true about the axis of symmetry? Well, it goes right through the vertex. That means that it has the same x value as the vertex. So we don't want to just write 1, right? That doesn't mean anything. We want to write x equals 1. Okay. All right. Determine the y-intercept. That is nothing more than plugging 0 into the equation. So f of 0 is negative 0 minus 1 squared, and then plus 6. All right, negative 1 squared is 1, negative 1 plus 6 is 5, and so we want to write this as 0, 5 for our y-intercept, and that should be the same as right on our graph. Okay, so those characteristics, not so bad. But we want to practice doing our x-intercept ones the same way we did the last example, okay? So let's copy down that equation. 0 equals negative x minus 1 squared plus 6. 0 equals negative x minus 1 times x minus 1 plus 6. Now, I always get folks who ask me, should I take the negative and distribute that first, or should I FOIL first? My recommendation would be to FOIL first. So do this part first, and then distribute in that negative sign after, okay? It doesn't really matter which way you do it. You just have to choose a method and stick with it. So 0 equals negative, let's see, x squared minus 2x plus 1, and then plus 6. And now let me distribute that negative sign. 0 equals negative x squared plus 2x minus 1 plus 6. Now, I will say this. When I'm factoring, I do not like to factor when the squared term is negative. So I'm going to cheat a little bit. I'm going to take all these terms and I'm going to move it to the other side of the equation, okay? So then I'm going to get x squared minus 2x, and let's see, negative 1 plus 6 is 5, so it would be negative 5 equals 0, okay? All right. Now this, if I try to set this up with the factoring that I did before, I want 1 times negative 5, that gives me negative 5, and then the middle number, negative 2, comes here. And so we want to ask ourselves, is there a pair of numbers that multiplies to make 5, but adds to make negative 2? And in this case, we notice that there are no numbers that do this, okay? And so in this case, we must use the quadratic formula, okay? This is not always the case. In fact, most of the questions that I ask you to do will be factoring, not quadratic formula, okay? So let's do the quadratic formula and see. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times 1, 2a. All right, let's see what that gets us. 2 plus or minus 4. 2 plus or minus 4 plus 20 over 2, which really gives us 2 plus or minus square root of 24 over 2, okay? We could simplify this more. I don't think that's really necessary, but all we need to do now is to write them as intercepts. So we would say 2 plus root 24 over 2 comma 0. That's one of the x-intercepts. And 2 minus square root of 24 over 2 comma 0. All right. And if we zoom in and color code, this point should be this point. All right. And the second coordinate down here should be the x-intercept on the left. All right, just because I've got the minus square root of 24 there. Okay. But if you run into a question like this, I ask that you keep everything in exact forms. Exact forms means square roots are fine, but no decimals. We don't want any decimals. Okay. All right, my friends, this is the end of part 2. I'll see you back here for part 3.